Let us understand what are trigonometric ratios, how do we calculate them, and how do we solve a triangle using trigonometry. The triangle being considered will be a right angle triangle. So, this is one of the first lessons for students taking trigonometry. We'll start with the very popular term SOHCAHTOA. So, everybody who begins with trigonometry begins with SOHCAHTOA, which basically gives you the ratio of sine, cosine, and tan, how they are related. In any right angle triangle as shown here, one angle will be 90 degrees. The side opposite to that is known as hypotenuse. And when we are trying to calculate a trigonometric ratio, it is with reference to an angle. Let us say the angle is A. If the angle is A, then side which is directly across is called the opposite side, as written here. So the side BC is opposite to angle A, and the side which is in between angle A and 90 degrees is called adjacent side. So now we have defined a right triangle with reference to the angle A. So if you see from A, BC is opposite, AB is adjacent, AC is hypotenuse. I hope this part is clear, right? So this is also a confusion in many students. Now let's come to the trigonometric ratios. When we say primary trigonometric ratios, there are three primary trigonometric ratios. These are sine, cosine, and tan, always written in lowercase, right? So you read them as sine, cosine, and tangent. Now, alone, they have no meaning because these ratios are ratios of two sides in a right angle triangle. Now, with reference to which angle, that should be mentioned, right? So, as I was saying, in this diagram, we will reference it with angle A. And therefore, we have written these ratios in short form. So, when trigonometric ratios are written in short form, we pick up three letters. So, for sine, it is SIN and angle A. So, we'll calculate sine of angle A. Cosine is COS of angle A. Tangent is TAN of angle A. So, in this case, we have picked up the first three letters of the word, as you can see. So, I hope that is clear. Now, a triangle basically with reference to the angle A has three sides: opposite, adjacent, and hypotenuse. So, their respective ratios, we could have these combinations. So, for sine, we have a ratio which is the ratio of opposite side length of the side we're talking about, and the length of the hypotenuse. For cosine, we take up the adjacent side with hypotenuse, and with tangent, we take opposite with adjacent side. SOHCAHTOA, which is so popular, is giving you a short form. I have my own acronym for the same. I write SOHCAHTOA as shown on the right hand side. Sine, ratio of opposite to hypotenuse, right? Makes sense, right? Cosine, adjacent over hypotenuse. So instead of writing it in a straight line, I have written it like a ratio, right? And tan, T for tan, opposite over adjacent. Makes sense. So that is my nomenclature of writing it. Well, you can make your own. Perfect. So feel free to use your own nomenclature. It is important that this is just an acronym. How do we remember it, right? That's all. Okay. Soon you don't need it because you'll remember it. Perfect. So now we understand that sine is the ratio of opposite to hypotenuse, cosine is adjacent to hypotenuse, and tangent is opposite to adjacent. Correct. So what we just did is understood few words, and what we are talking about is trigonometry. So let me also share with you what does it really mean and from where this word has come. Trigonometry comes from a Greek terms which means trigno, that is one part of the word, the other is metrikos. So trigno means triangle, right? So, and then metro comes from measurements. So, all the measurements in a triangle. In a triangle, there are six measurements to be done, three sides and three angles. So, with the help of trigonometry, we can actually find the value of all the three sides and all the three angles. So, to fully solve a triangle, that is, to find all the three sides and all the three angles, we should be always given at least three of them. So, we should be given three parameters. Means any combination of sides and angles. Two angles, one side, right? Or two sides, one angle, like this. Well, if you're given three angles, then you should remember that the triangle is not unique, because that means we are talking about similar triangles. We could make a triangle which is much bigger, right? So at least one side should be given. Great. So let's move on and see how we can remember them and how we can summarize what we have just done. So, what we just saw is that there are three primary trigonometric ratios, which are sine, cosine, and tangent. Trigonometric ratios have no units since they are ratios of the sides, and trigonometric ratios are written always in lowercase. It's kind of important for me to emphasize on this because I see many times students writing with capital letters. It makes no sense. And Greek letters are there like alpha, beta, gamma, theta, delta are commonly used for angles. Now, these are Greek symbols. Some students really get it difficult to digest this, but in trigonometry, we use lot of Greek symbols and alphabets. The word you can see comes from Greek, right? So, okay, great. And another way to remember is SOHCAHTOA. And my way is to write in the form of ratios directly. Sine as opposite over hypotenuse, cosine as adjacent over hypotenuse, tan as opposite over adjacent. So with that, I think you have understood quite a bit. Let's take up our first triangle. So here we are given a triangle whose sides are 12, 5, and 13. Well, we have also given a symbol for right angle. That means it is a right angle triangle. But it is a good practice to verify it. So can you check whether it is a right angle triangle or not? Well, check a symbol. That is, let's find what is 12 square plus 5 square, right? So 12 square is 144 plus 25, and that is 169. And 169 indeed is 13 square. So we see the Pythagorean theorem is satisfied. The squares of the legs, when you add them up, is same as the square of the hypotenuse. So definitely this is a right angle triangle. Now once we know this is a right angle triangle, we can actually calculate the trigonometric ratios. So let's find what is sine A. So sine A is the ratio of, as I've written here, opposite to hypotenuse, correct? So if you look from A, in that case you can see that side opposite is 5 and therefore I'll write 5 here, and hypotenuse is 13. So 13. So we get the value of sine A, right? Now let's find what is cosine of A. So COS, short form of writing, it is the ratio of adjacent side to hypotenuse. Adjacent side is the one which is between the angle and 90 degrees. In this case, it is 12 and hypotenuse is 13. You note that the sine and cosine ratios, maximum value could be 1 only since hypotenuse is the longest side, correct? For tan, it is opposite over adjacent And therefore, for tan A, we can now write down the opposite side length of 5 and the adjacent of 12. So we have solved our first triangle, finding the ratios, right? We'll later find angle also. So let's focus on the ratio first. Now, here's another example. This time, we have not given you the third side, but we have given you two sides and said that one of the angle, H in this case, is 90 degrees. I would like you to now pause the video and find the value of sine, cosine, and tan A. Uh, there is no angle A here, so we will see theta is there, right? So we'll work on theta, this. We are using the Greek symbol theta. So I would like you to find what is sine theta, what is cos theta, and what is tan theta. Is that clear to you? Now we are given only two sides. How do we find the third side? Well, third side is a shorter leg. Hypotenuse of 13 is given to us. So what we can do here is that we can do 13 square minus 5 square, right? And then square root. So once you do that, we get 12. Well, like the last triangle. But what I want to emphasize here is that if two sides in a right angle triangle are given, you can always find the third one. Use Pythagorean theorem. So we got the three sides, and once again, we can write down what, with reference to angle theta, are the values of sine theta, cos theta, and tan theta. Sine means look at the opposite side, which is 12 in this case, and then divide by the hypotenuse. Cos is look at the adjacent side, which is 5 in this case, and divide by hypotenuse. Tan is opposite over adjacent, so which is 12 over 5. Makes sense, correct? So once again, we have found the trigonometric ratios, but this time we did one additional thing, and that is we found the third side also, right? Great. So we could actually figure it out. Now let's look into how do we find the angle. So in this third example, what we have done is we are giving you two sides and we also have an exercise for you to figure out what should be this angle which is shown. So angle P. Now in a right angle triangle, we can always find the third side. So PR, the hypotenuse. PR should be equal to square root of the other two sides, which are 8 square plus 6 square, which is square root of 64 plus 36, which is 100, and square root is 10. So we know this side is 10. Now, we are given the two sides, and in this particular case, if I read the question properly, it says given triangle PQR, PQ is 8, QR is 6, and this angle is 90 degrees. Write primary trigonometric ratios in lowest terms for angle P. So let's do that. For angle P, what is sine P? Sine P means opposite side of 6 over the hypotenuse of 10. So SOHCAH TOA, right? So sine is the ratio of opposite to hypotenuse. I wrote it. Simplest form, dividing them by common factor of 2 gives us 3 over 5. Now let's look into cos P, which is adjacent over hypotenuse. So it is 8 over 10. Simplest form, dividing by 2 gives us 4 over 5. And then let's write down tan P, which is opposite over adjacent, 6 over 8, simplest form, dividing by 2 is 3 over 4. Makes sense, right? So we got this. Now here I will also tell you how do we find the angle. On a calculator we have inverse function. So from the ratio we can always find the angle. So sine P is 3 over 5. Angle P is what? So on a calculator, you can do sine inverse of 3 over 5 and calculate what it is. Now in the calculator, we have two modes for angle. One is degrees, the other one is radians. We'll go to the settings for mode and select the degrees for now. The default unit for angle, however, is radians. But we'll begin with degrees. So I've set my calculator to the mode degree. Now, sine inverse is a shift function. We'll press shift and sign, so we'll see sine inverse as I've written here with the bracket open. We'll do 3 divided by 5 and close the bracket and then press equal to sign to find the value. It gives me 36.869, which I'm going to write in one decimal place 36.9 degrees. Makes sense. So I used my ratio sine p to find the angle p, which is 36.9 or approximate to 37 degrees. Well, I could have used tan or cosine also. So let's figure it out. If I would have used tan ratio, in that case, angle P could have been also written as tan inverse of its value, which is 3 over 4. So once again, I am using my calculator to find what is tan inverse of 3 over 4. Shift tan function, it gives me tan inverse, and then 3 divided by 4 bracket close equal to. Again, it gives me exactly the same value, 36.86989765, rounded to 36.9 degrees. You see that. So once we have a ratio, we can also find the angle. So we got one angle which is 36.9. Now you can actually calculate what should be angle R. Can you tell me what should it be? Well, simple as that. The sum of all the three angles is 180 degrees. So sum of angle R and P should be 90 because 1Q is 90 degrees. Correct. So angle R is basically 90 degrees minus 36.9. And so you know it, right? So subtract from 90 this particular angle, you're going to get 53.1 degrees. So that becomes the other angle in the triangle. You see that. So we have now solved completely the given triangle. Makes sense, right? You can take up many questions to solve triangles fully. In the next video, we'll go into further details. However, here are a few questions for you. So ignore what I have written here, but you have a triangle here, right? So the triangle is given with the sides square root 5, 2, and 3. You can find the trigonometric ratios as a practice exercise and also find the given angle, which is theta in this case. Makes sense, right? Here is another example for you. This is a question why right there. So I could have given you a triangle with different ratios. 2x, not the exact value. Correct? So in terms of x, I've given you a triangle. So remember one thing, in similar triangles, all the angles are equal. And therefore, if we have this situation, we can exactly find the value of sine theta, cos theta, and tan theta, and also the angles, since these are just the ratios. So bigger or smaller triangle, if it is similar, doesn't really matter as far as angle is concerned and as far as the ratios are concerned. So ratios always written in the slowest terms will be same. I hope it makes sense. With that, we come to an end of this particular video and we'll continue exploring trigonometry in our series. Join us, and in case you want to learn directly from me, feel free to send an email to globalmathinstitute@gmail.com. Our students are right there on the top, getting admission to the best universities, even with scholarships. Thanks for your valuable time and all the best. Follow my book and bring alive the real experiences. Thank you and all the best.